Good morning, children. In our previous class, just we discussed few topics of electromagnetism, and I asked you to read the lesson of acids, bases, and salts. Because children, those who are coming to school, for them we are doing the revision because my portion is finished. Just the leftover topics, whatever it is deleted from the syllabus, just I am teaching the form of a summary. This lesson also electromagnetism, it is not there in the syllabus, and I am making them to write in a classwork, writing classworks and completing their projects. Please children, those who are at home, they are due to their personal problems, they are not coming to school. Please children, try to complete your classwork, projects and activity. Only 2 projects and 2 activities. And let me remind about your test, revision test. Acids and bases, salt is your revision portion. I am doing the 2 things, electromagnetism for 15-20 minutes, which is deleted but supposed to say that lesson. And next, revision also going in the class. Those who are at home, read that lesson, and next Saturday or one day I am going to give the question paper, answer that questions. Okay? Test yourself. If you are in the school, we are ready to correct your paper, but you are sitting at home, maybe transport facility, I don't know that your conditions. So from there you hear these video classes, observe the video classes and follow what we are doing in the class. Okay? On that day we discussed about that from the magnetism, when electric field is produced by the rectangular coil, which is a iron frame. Rectangular frame is wounded with the copper wire, and 2 ends of copper wire is connected to a battery. When it is connected to battery, around that it produces electric field, and around the electric field it produces the magnetic field. And this rectangular coil is placed under the influence of a magnet, and that magnet again produces a magnetic field. These 2 magnetic forces are perpendicular to each other, opposite to each other, makes our coil to rotate or move in a clockwise and anti-clockwise direction. That is a principle used in an electric motor. Electric motor is a device which converts electrical energy into mechanical energy. And we discussed about magnetic lines of force, magnetic flux density, and a straight carrying wire. When a straight carrying wire is connected to the 2 ends of a battery, and place a magnetic compass, how will be the direction of that? It is in a clockwise and anti-clockwise direction. Out of page is a clockwise direction, that is upward direction. When the current travels in a downward direction, it is said to be inward page, and the current in an anti-clockwise direction. There it can be explained with the right hand thumb rule. And second situation we discussed, when a current wire is passed through the 2 holes to thermocol or a plank. Take a plank, make 2 holes at equidistance and insert a copper wire. 2 to 3 turnings such that it makes a coil, and 2 ends of that coil is connected to a battery. What happens? Some current passes. It forms like a ring like this. So beneath that you place a magnetic compass. There we can see the deflection. This is a one more experiment. And next, a solenoid. Solenoid is nothing but a long coil which is fixed in a helix or a packed surface is said to be a solenoid. It looks like a spring, and 2 ends of that is connected to the battery. When it is connected to the battery, a current passes, and each pole acts as a bar magnet. The solenoid acts as a bar magnet, rays coming from the north and enters into the south. After when that we discussed about how the coil rotates, how the ring rotates. The direction of the current in the coil after the first half rotation is reverse. The coil will continue to rotate in the same direction. Thus, if the direction of the current through the coil is reversed every half rotation, the coil will rotate continuously in one and the same direction. How can we achieve this? To achieve this, we need to use 2 brushes, that is B1 and B2, as shown in the figure. The brushes are connected to the battery. The ends of the brushes are connected to the slip rings C1 and C2 which rotate along with the coil. Initially, C2 is in a contact with the B1 and C2 is in a contact with the B2. After off rotation, the brushes come into contact with the other slip rings in such a way that direction of the current through the coil is reverse. This happens for every off rotation. Thus, the direction of rotation of the coil remains the same. This is a principle used in electric motor. Electric motor is a device which converts electrical energy into mechanical energy. We have to learn that current carrying coil rotates when it is kept in a uniform magnetic field. What happens when a coil without current is to make rotate in magnetic field? So that this is the electromagnetic induction. Now let me talk once again about the electric motor. Let us consider opening a cap of the bottle, an example where two equal and opposite forces are act on that. Two forces equal in magnitude and opposite in direction must act on the either side of the cap of the bottle. These forces bring the cap into motion. Similarly, rotation. Similarly, the rectangular coil comes into rotation in a clockwise direction because of equal and opposite pair of forces. The direction of current in the coil is unchanged. It rotates up to vertical position. Due to inertia, rotates in a clockwise direction. But now the sides of the coil experience force which are in opposite direction. In the previous case, then it remains in a anti-clockwise direction. How could you make a coil rotate continuously? In the direction of the current in the coil, for every off rotation is reverse. The coil will continue to rotate in the same direction. Thus, if the direction of the current in the coil is reversed for every off rotation, the coil will rotate continuously in one and the same direction. How can we decide? How can we achieve this? Can be achieved with the help of brushes B1 and B2. See the figure here. C1, C2 are the slip rings commutator. B1, B2 are the carbon brushes and which is connected to the battery. A long rod is running from that. It is said to be a shaft. And the rectangular coil, it is known as armature, placed under the influence of electric field, under the influence of magnetic field, and around this electric field also produces. These two fields are equal in magnitude but opposite in direction, and this makes our coil to rotate in a clockwise and anti-clockwise direction. And for every off rotation, the direction of the current should be reverse. But it is not happening in this because of the brushes B1 and B2. It reverses the direction of the current, not the coil. It reverses the direction of the current, not the coil. So here this principle is used. For every off rotation, the current remains, the direction of the rotation of the coil remains the same. This is the principle used in electric motor. And what is the device electric motor? It is a device which is used to convert electrical energy into mechanical energy. What are the important parts of this? That is rectangular coil and wounded with a copper wire. It is placed under the influence of a Arsham magnet, and both ends of that wires are connected to the carbon brushes B1 and B2. They are also known as the commutators, slip rings, and it is C1, C2 are the commutators and B1, B2 are the carbon brushes. The both end of this copper wires is connected to the battery. A long rod travels in this in anti-clockwise rotation. It is said to be a shaft. So electric field produces magnetic field around that, and this rectangular coil already it is influenced in the magnetic field. These two equal and opposite makes our coil to rotate in a clockwise and anti-clockwise direction. But direction of this is not a reversed. Only The carbon brushes are reversing the direction of the current, not by the coil. Okay, this is a relation between electricity and magnetism. Magnets are affected or produce the electric field, and electric field produces the magnetic field. Okay, let me remind you about your classwork, children, projects, and submit in the school. Now we are going to find the relation between a current in the current when it is rotated in magnetic field. Further, a simple activity is given, and that is given as a magnetic electromagnetic induction. Take a wooden base as shown in the figure 13a. Fix a shaft iron cylinder on the wooden base. Wind copper wire around the soft iron figure. Now take a metal ring which is slightly greater in its radius than the soft iron cylinder and insert it through a soft cylinder on the wooden base. Connect the ends of the coil into an AC and source which is switch on the current. Switch on the current. What do you notice? You notice that metal ring is leviated on the coil. Switch of the current, ring will jump into the air very dramatically. Remove the AC plug and connect to DC. Observe what will happen. The difference in the behavior of the two cases. What forces supports ring against gravity when it is being elevated? Could the ring be elevated when DC is used? The metal ring elevates when AC is used. Therefore, net force on it should become zero according to Newton's second law. The free body diagram of metal ring is shown in the figure 13b. Weight act on it in downward direction. To balance that, equal magnitude and opposite in direction should act in the figure 13b. What is the unknown force acting on that metal ring? In this activity, AC is used. AC changes both its magnitude and direction in regular interval of time. We know that current through the coil produces a magnetic field. So the other end behaves like the south pole for the certain magnetic time interval. For the next interval, coil changes its polarities. Hence we say that coil undergoes changes in its pole in the same time of intervals. The levitation of a metal ring is possible only when metal behaves like a magnet, and it should change in the polarities in the same time interval. This is the explanation given. Now comes to the Faraday law. Let us understand result of activity 9 by the following hypothetical activity. Connect the terminals of a coil to a sensitive ammeter or galvanometer as shown in the figure 14. Normally, you should not expect any deflections on the needle in the galvanometer because there is no electromotive force in the circuit. Now, if you push a coil or a remarkable things happen while the magnet is moving upwards. The coil in the needle in a galvanometer deflects, showing that current is at rest. The magnet is moved away from the coil. The needle in the galvanometer again deflects but in opposite direction, which means that current is set up in the coil in the opposite direction. If we use the end of south pole of a magnet instead of a north pole in the above activity, the experiment works just as described, but the deflections are exactly reverse. Further experimentation enables understand that relative motion of magnet and coil set up in the circuit in the coil. It makes no difference whether there is a magnet is moved inward towards the coil or the coil moves towards the magnet. Wherever there is a continuous change of magnetic flux linked with the closed coil, a current is generated in the coil. This is one form of Faraday's law. The current is generated is called induced current, and it is set up by induced electromotive force EMF. Faraday observed that changes in the magnetic flux through the coil are responsible for the generation of current in the coil. So induced EMF is generated in a closed loop is equal to the rate of change of magnetic flux passing through it, and this is known as a Faraday's law. What is a Faraday law? he took a copper wire and two ends of a copper wire is connected to the galvanometer, which shows the amount of current. Now just he took a magnet. Let me show you. This is a diagram which is showing figure 14. He took a magnet and moved near the galvanometer, that is copper wire ring. What happens? Just we saw the deflection in a ring. What it shows? Moving the magnet is nothing but changing the magnetic flux. When a magnetic flux are changed, a current is produced in a galvanometer. It shows a deflection. This gave the idea to the Faraday that changing the magnetic flux, we can generate the current. The induced EMF is produced due to changing of magnetic flux is known as Faraday's laws. Okay, clear? That's all for today, children. In the next class, we'll discuss few more topics, and let me remind about the acids, bases and salts. Read the lesson as a part of a revision. So physics portion is completed. Just leftover topics, deleted topics I'm teaching. This lesson also it is not there in the syllabus.